Welcome to lecture number 40 of microcontroller 8051 series. In this lecture, we will discuss on keyboard interfacing with 8051. Actually, this is a generic thing, LCD, keyboard. What we discussed in previous lecture, we discussed LCD. In this lecture, we'll discuss keyboard. In coming lectures, we will discuss A to D converter, D to A converters, or I to C, all these things. These are all generic things. If suppose you are working with other microcontrollers like PIC 16 series or 18 series or Renesas RL78 or whatever is the microcontroller, things will remain same because every microcontroller will have port, and every microcontroller we can configure the port as an input port, output port, and all these things will be interfacing with the ports. So you must have a basic knowledge of the port programming, which I had already discussed in previous lessons, how to configure the port as an input port, output port. For 8051, we need to set the latch and all these things. But for other microcontrollers, there may be some specific registers which we need to set or reset to make the input port as an input port and output port. So these are all generic lectures actually, not specific to only 8051. You can convert that logic to other microcontrollers as well. So in this lecture, I will discuss a program in embedded C, how to read a keyboard and all that, and a flow chart, all these things, right? So let us start with keyboard interfacing. See, this is a keyboard here. I have this keyboard here. This type of keyboard you can get from market. Anyway, whatever the keys mentioned here, like 1 2 3 4 A B C D or whatever, you can change. Actually, what is written here not mandatory. That same thing you will consider. You can define your own you can say array, two-dimensional array rather, to define what each key you want. Okay, this is just an example. You can have your own set of keys as per your software, right? So this keyboard available in the market has some switches. So we can press a switch to make the key active, or we can release the switch to make the key inactive. So assume that there is some wires coming out of that keyboard, maybe like x1, x2, x3, x4, y1, y2, y3, y4. So this I can say as a row, and this I can say as a column wire. So we can have set of row wires. This is an example of 4 by 4, means we can define a 16 keys here. You may have other like 8 by 8 also, because in 8051 we have 8-bit port. So you can have a 8 by 8 matrix as well. So this is a 4 by 4 matrix. So these are we can say as a row key rows, and these are we can say as a column, and row column can have total 16 possibilities, right? Suppose I press this key here, for example I press 1 here. So effectively what I am doing, I am shorting x1 with the y1. When I press suppose D, this key here, what effectively I am doing, I am shorting x4 with y4. Now it is understood that user will press only one key at a time. So we are assuming, or we write a software in such a way that assumption is that only one key is pressed at a time. Okay, and user will start from all keys released. So initially all keys should be released, then user can press a key and that key will get detected. And once that key is suppose user don't release that key, then other keys will not be detected, or it is not like that case. The key once pressed will come continuously. It's not like that. Once a key is pressed, for detection of any other key, what user should do, user should again release the key and again press the key once again. So the your logic or the flow chart we are writing in such a way, assuming that initially all the keys are released and user can press only one key at a time, and user should again release that key, so that next key or the same key suppose user press key 1. Okay, so that will be detected one time. So user again want the same key to be detected, then user should release this and again press it. On that assumption we are writing this software, or our flowchart will be like that. Okay, so when we want to interface this type of you can say matrix type of keypad or keyboard with any microcontroller, the things we like, we can have some port 1 and we can have some port 2. Okay, and this port we are assuming as a output port. You can assume the lines like this. Okay, the arrow is like this, so it's the output port. And I can say that these are the rows. Rather, I will say this is row 0, row 1, row 2, and row 3. And these input port is a column actually. I can say this is a column 0, column 1, column 2, and column 3. So it's a row column, and all rows and all columns are connected with the help of some pull-up resistor, maybe 4.7K or 10K, to the VCC. So if you press a certain key here, suppose this key you want to press, what you are doing actually, you are shorting this two lines actually. See, in this case you can assume when I press 1, I am shorting Y1 with X1 like that. So same is here, only I want I have drawn this different figure to demonstrate that we will connect the port, you can say 4 lines as an output and 4 lines as an input port. Maybe this will be the same port. You can have port 1 taken in case of 8051. So 4 lines of the port 1 will be output and 4 lines will be input, right? Like that also possible. Okay. So don't mind here 1, 2, 3, 4, 0 or whatever I have written here, because this image is different, this image is different. So you may get confused that here I have written 1 and here I have written 3. And that's not a issue actually. You can write anything on your front panel like this. What you will do in the matrix, that will ultimately decide in the software what exactly the key for you. But generally it is recommended that whatever is written here, same should be the in the software, that is recommended. So don't bother too much about the digits I have written here. Just consider important thing is that this is a rows and these are the column, and this is my first key, second key, third key, like that. Okay, and let us discuss the flow chart first of all, how we are going to handle this actually. That is very important. See, what we'll do initially, we are assuming that initially all keys should be in release condition. So how to detect a specific key? Let me tell that how to detect a specific key first of all. Let us take a very simple and very basic example. Let us take that P1.0 is my row and P1.4 is my column. Let us take this as a X1 and this as a Y1, and this pull-up registers are there, and this is my key. Okay. Suppose I want, when I press this key, what exactly will happen? This line and this line will get connected. Okay, rather I will say X1 will be connected to Y1. Now, in order to detect this, what we'll do? We will send 0 on this line. See, we will send 0 on this line. Rather, I will ground this pin. P1.0 will be 0. Let us assume P1.0 is your output line. Okay. And suppose in case this key is not pressed, it's in release condition. What you will get at the output? Sorry, what you will get at the column input? What you will get at the Y1? You will get Y1 is equal to VCC, rather logic 1. See, you will get VCC from this side. When even X1 is X1, you have given 0. And assume this key is in released condition. Okay. Now suppose I press this key. Suppose this key is in pressed condition. What will happen? And when we send 0 from this side, actually that 0 will come here, and that even Y1 will get grounded because X1 and Y1 are effectively connected. So Y1 is grounded here. So you can say that when you read this Y1, you will get Y1 also equal to 0, provided this key is in pressed condition. So this is a very simple logic. You send 0, and if you get 0, the key is pressed. And if you send 0 but still you are getting 1, key is released. Okay. So this is the way we are going to test. Now what we'll do? Initially, suppose we want to check all keys are in release condition. All keys are in release condition. What we'll do? We'll send 0, 0, 0, everywhere 0, 0 on all the 4 rows. And we'll read all the 4 columns. If all the 4 columns are still 1, 1, 1, 1, it indicates that no key has been pressed. So all keys are in release condition. Okay. If suppose if this key is pressed, what will happen? So you will get 0 here rather, right? When you send all zeros, this 0 will come here, and on this feedback path this 0 will come here. So when you send all zeros and you are getting 0 on particular column, it indicates that particular key is pressed. This is very simple. Now suppose now you will get the idea that particular key is pressed. Now you want to actually which key is pressed, how to detect that. Now this question arises. For that, actually the logic is you don't send 0 everywhere. You will try single rows. You will send 0 on row 0, rest are 1, then 0 on row 1, rest are 1, 0 on row 3, rest are 1, and 0 on row 4, rest 1. If you send 0 on row 4 only and you are getting 0 on column, see row 4, row 0, row 1, row 2, sorry, just take this as a row 2, just this is row 2 and this is suppose row 3. See, we are starting from 0. Okay, so 0, 1, 2 and 3. In column wise also you can take column 0, column 1, column 2 and column 3 here. So don't take this nomenclature. I'm just erasing that nomenclature time being. So take this as row 0, row 1, row 2, row 3, and this as column 0, column 1, column 2 and column 3. Okay, so when you send all zeros, all rows zeros, you are sending zeros on row 0, 1, 2 and 3, and you are getting column, you are reading column. So what we were discussing, actually, suppose you are getting 0 on column 3. Okay, now you want to understand exactly which key on the column 3 is pressed. In that case, you will try one row at a time. You will send 0 on this row, you will read all the columns, then 0 on this row, read all the columns, 0 on this row, again read the column, and 0 on this row. When you send 0 on this row, you will get 0 on the column 3. So you will understand that this particular key on row 0, column 0 is pressed. In this way, okay, so we are discussing on this. Now see, let us take the full-fledged system here, how it is happening. So this is just an expansion of the same thing. I have here total you can say 16 keys interface to the 8051, and this is row 0, row 1, row 2, row 3 and column 0, 1, 2, 3, right? So row 0 row up to row 3 are output, and C0 to C3 are the input pins, right? So now the as per our flow chart, what we will be checking first of all, we will checking that all keys should be in release condition. Okay, so how to check that? To check that, what we'll do, we'll send 0 on all the rows. See, when you are sending 0 on all the rows, suppose you are sending zeros on all the rows, what will happen? In suppose all keys are released, no key has been pressed, so you will get VCC everywhere. So you will get 1, 1, 1, 1 in all the keys, right? So in this way, you will get all the ones see, all columns should be 1 if all keys are released. Very similar to this was just a single key example. Here it is 4x4 matrix. Now suppose you assume that a particular key is pressed. Suppose let us take an example that this key is actually pressed. What will happen if the particular key is pressed? When we send 0 everywhere on all the rows, what will happen? This 0 you will get effectively back on this C3. So what you will get in that case, these are all ones, and this you will get 0, right? So this will indicate that something is pressed, but you don't know which key is pressed. Actually, you will understand that something on the column number 3 is there, or the key pressed is somewhere on the column number 3. That you will understand. But now you want to find out exactly which key. On column 3 there are 4 keys, right? So you need to find out now which key is pressed. For that, what you will do? For that, the next step will be what is to be done is, let us undo first of all this, and just undoing the things. Oh, sorry, redo. So what you will do? You will try single rows. Means you will first send 0, 1, 1, 1. Means only first row you will send 0. And suppose your key pressed was this key, right? And what you will get in this case? You will get, see here 1 is sent. So 1 will received. So here still you will get all ones. Because your third row where the key is 1. So you will get 1 here. Still you will not able to find out that this key is pressed. So you will try, then in that case you will try the second row. Means what you will do? You will send 1 here, 0 here, 1, 1. Still you will get all ones here. Again, then you will try third row. Means you will send 1, 1, 0, 1. Still you will get all ones. Because still the key you have pressed is here, and you will get 1 from this side, and other keys are already released, so you will get 1, 1, 1, 1 still. Okay, now the point is arise. Now suppose you will send like this 1, 1, 1 and 0 here, and your key pressed is this, suppose, as we discussing that. So what will happen? Now from here you will get 0 and rest will be 1, 1. Now you can easily find out that the key pressed is on row 3 and column 3. And then you can find out from the, you can say exactly which key it is that is already with you in some array, maybe 2-dimensional array. So you can easily find out, whatever you feel right for this key, you will take that data. Okay, in this way the program will be there. So I'll be come back to the flow chart once again. Now how will you do? So first thing is that you will ground all the rows. As I discussed, first you will send everywhere zeros. You will read all the columns. If you are getting 1 everywhere, what you will say? All keys are open. So you will check if all keys are open. If suppose you are getting no, means still we are doing the previous, still something is there. See, this flowchart assumes that initially all keys should be open. If all keys are not open, it will just wait here and here. And if suppose all keys are open, means you are getting all columns as 1, now you will again check for some keys to be pressed. You will understand this, why we check all keys open when we come back to end. See, now you will check for the key press. If some key is pressed, if it is yes, now how will you get some keys pressed? Again you will send all rows are 0 and you will read all columns. And if some column is 0, you will understand that something is pressed, but still you don't know what is to be pressed. Again, but you need to wait for key debounce as well. Sometimes what happens, because of some noise and all that, you assume, you think that something is pressed, but still something is not pressed. So you will again give some delay, key debounce delay, and again you will read all the columns. Still you are getting keys pressed. Now you are sure that something is pressed. Now it is time to find out exactly which row and which column actually. So you will ground rows one by one and you will read the columns, and accordingly you will find out exactly which row and which column, and then you process that key and you will come back. Now see, user has pressed something. Now again you want to check. So first user should release the whatever pressed earlier. That's why in the beginning we think that all keys should be in release condition. Now you will understand why we are checking this first step. All keys should be in release condition. Anyway, so same thing we will write in a software way. How to do that? I will come to the next slide. Now see here. Now see this diagram purposely here available to easily understand. See, VCC part I have just keep to save the space. So you can assume that the same diagram what we are discussing R0, R1, R2, R3 and C0, C1, C2, C. So in the software we will define what is there on which, see what is row 0. See, p1.0 is a row 0, p1.1 is a row 1, p1.2 is a row 2, and p1.3 is a row 3, like this. And for column 0 is p14, column 1 is p15, and column 2 p16, and column 3 is p17. See, whatever is here is here, okay. Same thing, only it makes easy when we define S bit. So instead of referring to the port pin, I can say row 0, row 1. See, this makes your life simple. In future, in another hardware, suppose this port is different, so you don't need to change everywhere in the software. You can easily do the changes only at a certain, only at the top, and the software will be ready for you. Okay. So in this way, I have written here all these things. You got about the S bit. What is the use of this S bit here? It makes our life simple. If hardware changes, we just need to change these lines and it will be ready. Okay. Now there are some other things I have done here. Row port, column port. See, actually I have the same port, P1 as a row as well as column. Only lower nibble is for row and upper nibble is for column. Okay, so same port I am using. We don't have very much luxury of the ports in microcontrollers. We have to manage in the same port and all that. So 4 lines actually as a output and 4 lines as a input. That is how we can handle in the software. Now see, all rows 0. See, when we want to check all keys are released or any key is pressed and all that, we make all rows as 0. So when I say all rows 0, actually what I will be doing effectively, I will sending 0 0 0 0 on all row 0 to row 3. So everywhere will be 0. So this, when I'll write this all row 0, actually a compiler will insert all these lines actually. Similarly, test row 0 will be what? Making only row 0 as 0, rest are the 1. Test row 1 is making row 1 as a 0, rest are the 1. Test row 2 is for making row 2 as a 0, rest are 1, and so on. Row 3 for this one, like that. So in program you will find this actually. So that will make, actually a compiler will replace with these lines as per requirement. Now when to test row 0, when to test row 1, actually you must have understood now, as we discussed in previous slide. Now this is actually the matrices. See, you can define a 4 by 4, you can say as a array, 2-dimensional array, and in that you will declare about what you can say. See, 0 1 2 3, for suppose this keys, this 0 1 2 3, then 4 5 6, like that, 7, then 8 9 A B, and C D E F, whatever you want actually, whatever you want as per your requirement, you can write in the 2-dimensional array, and this array will take when we want to detect the key press, right? So it is up to you, whatever on the front picture, same thing you can do, or different thing you can do as per your requirement. Okay. Now some other variables like unsigned char column press, unsigned char key press. This, just neglect this cursor position actually. I have not used here. Now pole key release and pole key press. These are again some important function. Confirm key press. This is again important function. These I will discuss all these functions. Just for a time being, there are some function. Pole key press will check if any key is pressed. Okay. And pole key release will check if all the keys are in release condition, and confirm key press will, after debounce, will check whether still the keys are some key is pressed, is it really pressed or not. That is what the confirm is there. And these functions are for testing single rows, like when I want to send 0 on the row 0, I will use this function as we discussed, because we need to find out exactly which key, exactly which row and which column, so we need to test single rows, like what. So these are about the important functions and variables and all that. Now we'll start the main function. See, I'm not writing all program here. That will be just a repetition, so just we'll understand what is happening. See, this is one flag here, unsigned char flag. Initially that flag is 0. Okay. Now this while one is at infinite loop. Suppose you want this program to run infinitely, continuously checking the user input and doing some process depending on if key is pressed. So this while one starts here, okay, and while one is ending here, suppose, and your main starts here and suppose main ends here. This is the end. So this is what the complete while one, and in main this is the end of main and this is the end of while one. Now in the very beginning, what we are checking, pole key release. We want all keys should be in released condition. So we are checking that all keys should be released here. If some keys, if the keys are not released, we will stay here and here only. And now suppose if some all keys are in release condition, now we'll come here, we'll poll for any key press, if something is pressed or not, we'll wait for that. If suppose we get something is pressed, then we call some delay, maybe 20 millisecond key debounce delay. This you need to adjust as per your requirement. So this delay function, already we have used delay function in many projects. See, this is the count for me, assuming some 20 megahertz type of crystal. This count may be different for you. You need to find out exact count in your case, depending upon your microcontroller, depending upon your crystal and all that. Okay, anyway, we want suppose 20 millisecond delay. That is a key debounce. Key debounce will ensure that there is really key is pressed. This is something, sometimes we get a false assumption that key is pressed because of noise and all that. So we give some delay and again we check, again we'll confirm the key press. See, this confirm key press is, again we'll check whether really key is pressed. If suppose we'll confirm if it is really key press, this flag will become 1. If otherwise, flag will remain 0. So we are just checking, this do while loop will continuously check for the flag. Actually, if the flag is not equal to 0, okay, then will come out and that will confirm us that okay, so this if flag is 0, this will become 1. So we will be again doing do while loop. We'll again check for key press and again debounce and again confirm. If it is really pressed, then confirmation will make the flag as 1 and will come out of this loop. Now here what we'll do, we'll test for row 0 press. Okay, and if suppose if it is row 0 is means whatever is pressed in row 0 will make the flag 1. Otherwise we'll check for row 1 press. Similarly row 2 and row 3. See, LC part will be just copy paste. Initially we'll check for row 0, then we'll check for row 1, then we'll check for row 2 and finally row 3. If suppose when we check row 0, what happens? This function will be called, and if this function returns value as 1, flag will become 1. Okay, and switch depending on the flag what we are doing actually. Sorry, this flag will not become 1. Flag will give us the exactly the bit pattern. Sorry, this flag will return a bit pattern actually, and in that bit pattern may be either E0, D0, B0 or 70. See, depending on what, if it is column 0, this bit pattern will be like this. See, we are assuming P1.4 to P1.7. These are what P1 dot, we can say 4 to P1.7. Rest of the bits are 0. Don't bother about the rest. It's actually rest of the bits are here output pins. So only upper nibble, this E, is what we will be getting on P1.4 to P1.7. So this flag will get exactly the bit pattern about the column. So if that bit pattern matches with 110, you can assume that C0 is low. So you can assume that whatever the key pressed is on row 0 and column 0, and from matrix or from the double-sided array you will take the input as key pressed is actually 0, and then you will process here whatever operation you want to do. I have just skip that part. You will process, you may display that key or whatever you want to do. then it is a break. If suppose that bit pattern is D0, D0 bit pattern means what? This is 1, this is 0, this is 1, this is 1. Actually, in that case, see, look at this bit pattern. Only D part you consider. Don't consider lower nibble. Lower nibble is for P1.0 to P1.3. That is output pins. You just focused on D part. If that upper part, upper nibble is this, you will be clear that column 1 is and row 1 column 1 means this key is pressed. So you will take this as a input. Likewise, other bit patterns according to column 2 and column 3. So if suppose this is what you get, it indicates that this key is pressed, means on row 0 column number 3. Now suppose your key pressed is on not row 0. In that case, what will happen? In that case, you will do this testing. Okay, you will do this testing, means you will test for row 1. Accordingly, if suppose that is not the case, then you will do for row 2 and then finally row 3. Everywhere your cases will remain same. Only in this part, what will be happen if suppose your any case matches here, it will be very sure that your key will be somewhere on the row 2. If suppose row 3 press, then somewhere on the row 3, and according to that you can expand this logic and you can find out exactly what is the row and what is the column, and according to that exactly from this two-dimensional array what is the value of key has been pressed. So this flag is used here to get the return value. Okay, and that flag is actually used initially to confirm the key press only. Okay, so this flag is, I have used it at multiple ways. Here it is for confirm key press. So here it will get either 1 or 0, true false type of value, rather I can say in C it is 1 or 0, and here it will get the return value from the bit pattern about the columns we read, right? Now it is a time to discuss more on exactly how these functions, what we discussed, the important functions like what you can say, poll key release, poll key press, and confirm key press, and test rows, exactly how they are working. And this is just a repetition. See, else if will be again test row 2 press, test row 3 press, and so on, right? And again each will have the same cases, means case only what will happen, your key will be different. For row 1 your keys may be out of these 4, for row 2 your keys may be out of these 4, and for row 3 your case may be out of these 4, right? So it is just a copy paste. That's why I'm not writing the same thing. See, this what is there same will be all row 0, row 1, row 2, and row 3. So you can write it easily, no issues. Now we'll go to the next slide. That is exactly the how these functions are. See, again I have written this. See, I have shown this sketch here for ready reference. Now let us see how we'll check for poll key release. See, initially all keys should be released. That is what we are checking here in this function. Now in this function, what we are doing? We are making all row zeros. Now what is all row 0? Sending all row 0, row 1, row 2. See, this actually already declared there, but I have written here for you to readily refer here. No need to write this code here. This is whatever I have write here. I have written here to make easy to refer. That's why. So all row 0 means, see, R0, R1, R2, everything will be 0 in that case. Okay. Now column 0 input is a column port. See, column port is what? You see, your same port is column, same port is you can say row here, but it is P1. You read this P1 is a column input variable, and you will make lower bits 0 because lower bits are actually output bits. So you will just mask the lower bits, or you will AND it with the F0. So rest of the bits, unwanted bits, are 0. Now if your column input is not equal to F0, see, you will repeat this till your column input is not equal to F0. Means what? When all keys are released, you will get 1 1 1 1 here, right? Means in that case only your column input will be F0. So you want to wait for all keys to be released. So you will repeat this do while till all keys are released, means column input is not equal to F0. When column input is F0, it indicates that all keys are released. So you will come out of this loop, means you will confirm that all keys are released. Now this function is actually called in the very beginning. See, I will come back to the previous slide. See, we are calling this function at the very beginning to ensure that all keys are released. Now suppose all keys are released, then we'll come here. Now it is different. Now we are actually waiting for some key to be pressed. So what is different? See, this function and this function, everything is same, only look at this. It is equal to F0, and here it is not equal to F0. See, when is equal to 0, it will be waiting till is equal to F0. When it is not equal to 0, key is pressed. So we are polling for key to be pressed, and here we are polling for key not pressed. Only difference is that. If some keys is pressed, it will not equal to F0, so we will come out of this loop. Now where we'll go? Let us come back. So we'll give some delay, that is key debounce delay, this delay here. Now again confirm key press. Now what is confirm key press? See, this is a confirm key press. This confirm key press will do the same job. If it is F0, it will return 0, and if it is not F0, it is 1. See, still it is not F0. It indicates that key is really pressed. So in that case, your flag will become 1. And if your flag will become 1, you will come here. Otherwise, you will again go for key press. You will assume that there was some noise. So it means really key was not pressed, and you will poll for key press. If suppose it is really pressed, in that case, flag will be 1, and you will come here. Okay, why flag will be 1? Because this will return 1 in that case. Okay, now what will happen next? That is again interesting. See, now you will test row 0 press. Now test row 0 means you will send 0 here, rest are the 1, 1, 1, right? So what will happen? Test row 0. Now what test row 0 will make? Row 0 is only 0, rest are the rows, rest of the pins are 1, 1, 1. See, it is hidden here. P1.0 is the topmost pin. Okay, that should be 0. Rest of the pins are 1, 1, 1. Okay, so you will get test row 0. Again, you will check the input. Again, you will AND with F0 to make the lower nibble unwanted part as a 0. Then you will compare that with F0. If it is equal to F0, you will return 0, because whatever you are searching is not on the row 0. And if suppose it is not equal to F0, you will return that column input. That column input will have exactly any of this bit pattern, maybe E0, D0. See, if it is not F0, means it may be either E0 or maybe D0, maybe B0 or maybe 70, depending on exactly. Suppose first key is pressed, first row, first column, in that case it will be E0. If the first row, second column, in that case it will be D0. If the first row, third column, in that case it will be B0. And first row, fourth, last column, in that case it will be 70, like this. Okay, so it will be any one of this. Now suppose we will come back to next. See, if this function returns 0, means you are getting F0 on all the columns, it indicates that whatever you are searching on, not on the row 0, it may be on row 1, row 2, row 3. So in that case, there may be other functions like test row 1, test row 2. Okay, those functions will be very same to this function. Only here you will, instead of sending test row 0, you will send test row 1 and test row 2 and test row 3. Now what exactly test row? That you can easily understand from here. So just copy paste part is there. That's why I am not writing. You can easily write a code Using this knowledge, you can write a code for any other microcontroller, maybe pick microcontroller, Renaissance, whatever the microcontroller is. See, logic for the keyboard interfacing will remain the same. Thanks for watching.